All right, hello everyone. Good afternoon. My name is Jimmy. So today's topic is about web API security in Azure. None of these things I really wanted to learn about as a consultant, but I was forced to. And because I was forced to, now you're forced to because you're sitting here. So my day job is really just like building systems and applications, and like business sort of applications, those sort of things. But as a consultant, I'm kind of forced to learn and implement things that are, maybe not interesting or relevant to me, but this one in particular was one that was kind of forced upon me. I am not a security expert whatsoever. So if you have any questions, I'll probably just direct you to Google because I don't really know. This is all the things that I was forced to learn about when trying to implement API security in Azure, which you think would be like super straightforward and simple because, Azure has all these docs and libraries and stuff. But it turns out that things aren't so simple when you actually have to put them in practice. So really, this talk is from a client of mine that was going from an on-prem application where things were very simple, and they were going to Azure, which things were much more complicated. And so this was me having to learn what was possible and feasible there, and make recommendations, and then implement their security system up in Azure. Most of my experience though with like security, besides just like giving it to someone else to do because it's not usually my job, is a much simpler sort of picture of security where usually the apps I build are just like this, where there's a browser, there's a server, and there's a database. And I just have to make sure that like no one crosses that boundary from the server to the database. And usually that's a pretty easy thing to do. Typically, though, my applications, I like things simple. I don't like Angular. I don't like React. I don't like any spas at all. And so I'll usually just like do some kind of cookie authentication where a cookie goes back and forth between the client and the server. But this client didn't like this simple picture. They wanted to make things even simpler with, of course, microservices. And so instead of a single client talking to a single server, and that was the end of the day, instead it was a single client talking to a single server that then talked to a whole bunch of other servers behind the scenes that would then talk to either databases or other APIs or on-prem systems. It became much, much more complicated. I did not advocate for this picture. This again was like the picture that was given to me that said, okay, today we're doing cookie authentication, which is very straightforward and simple. Now we're going to do this. So go ahead and secure this for whatever that means. So the first thing I had to figure out was, okay, today they were using cookie authentication. How do we make sure that even just that initial conversation between the client and this BFF, which is a backend for frontend, which is an API that talks to other APIs, how do we make sure that that initial communication is secure? So for this client, I didn't have to worry about that, luckily. That external communication between the client and this initial API was going to be done via some other identity provider. So in this case, for them, it was Auth0. Initially, it was going to be Identity Server, I think. And then they were migrating to Auth0. So for that initial sort of handshake of like, okay, the user has to put in their username and password, they go and get the challenge, they go to the website, they come back, and they get the whole OAuth 2 flow. That was already taken care of for us. My team was these microservice teams. So we had to worry about what happened after the request came in from the front end to our backend for front end. How do we secure everything beyond that? So we had some questions like, well, how should we approach securing those internal Azure service communications? So when I have the external API that has some kind of like external provider associated with it, from there to our internal services, how should we secure that? Now, if you rewind me like 5 years ago, I would have said like, well, just make sure I don't have external requests. But otherwise, that should be good, right? If we just make sure we don't get any external requests, we do the network-based security, then that should be good enough. But then they showed us like, no, that's actually not good enough. If someone were to gain access to the internal security, then they can get access to the internal data via these APIs, and that's not what we want. So probably not nothing. And the other aspect we had to worry about was they were on-prem systems because they were migrating from existing monolithic on-prem applications up to Azure. We also had to worry about how those on-prem systems should authenticate and authorize our APIs inside of Azure. So they hired some security consultants who came up with a lot of buzzwords. The biggest buzzword I hear today is called zero trust. Has anyone heard this today? Zero trust. So I think this is a term invented by consultants. I am one as well, so I am good at inventing these sort of terms. That describes an ideal of how things should work, but without any sort of details of how it actually will work in practice. So we were told like we're going to implement a zero trust model where it's like never trust, always verify. Okay, but what does it actually mean in practice to say never trust, always verify? Well, that was like, we asked the consultants, like, so what does this actually mean in Azure? And they're like, thank you very much. We'll send the invoice, and they were gone. So we're like, okay, typical consultants. So it was up to us and our teams to figure out what does it actually mean to implement this kind of model where I can't just say, let's just hope that the network security model is good enough, where we lock down IP addresses and network traffic. But if some like either rogue service or even just someone remote desktoping and they got access to the network, we wanted to make sure that they couldn't get access to the data. One of the big reasons for this was this company that we're doing this for was dealing with healthcare data, which in the States has a lot of rules and regulations. Well, it's EU here too, right? So there's rules and regulations about who can access what data. And with healthcare data in the States as well, there's even more kind of business rules about who has specific access to which specific data. So not just protect the personally identifiable information, but the healthcare data as well should be accessed by certain kinds of people or certain people with certain abilities or certain acknowledgements, things like that. So he said, okay, just saying that we have access to the network is not good enough. We need to perform some additional authentication and authorization here. So our first, just guess at doing this, because I tried to go for the very simplest thing possible, was can I just four-letter word in software development, can I just flow the user token? That is, this person here and the client authenticated against Auth0 or whatever external identity provider. So I know who they are. Can I flow that user token from that API to all the other backend APIs? But we ran into many problems with this, one of which were those on-prem systems over there on the right. Those on-prem systems were not hooked up to this external identity provider. There were, a half dozen or more internal systems that each had their own individual authentication mechanism. Some were like, well, you're Active Directory, so we know who you are there. Some were like, no, we have our own individual username and password. So we don't have this token from Auth0 available to use in these other backend services. Now we could try to make every single service understand every single kind of token it could be passed, and we tried that, but it would just become this explosion of having to understand every single kind of identity that would come in through the door. So that was out. Again, we'd also try to go back to the security folks and say, can we just not security? They said no to that as well. So we actually did have to secure all these incoming calls to our different microservices. So for us, we decided that our solution was going to be not Azure AD. Thank you, Microsoft marketing people. It's now Intra ID. I guess Active Directory is very old technology, so they just renamed it Intra ID, which sounds like something you could get from a doctor, I guess. I don't know. So it's all the communication from either inside of Azure or from internal systems that were still not inside of Azure but still internal to the company. We said all of those communications were going to be done through Azure AD Intra ID. Now, the choice of this was also dependent on whether or not we were going to be able to use Auth0 or not. So Auth0 does have the ability to authenticate machine-to-machine sort of things. But this team was also trying to integrate all those other backend systems, and they were already like a year and a half late of delivery. So we said, let's not depend on this, because it may not ever be delivered. So we'll just like depend on the things that we actually know, which is over here in Azure. By the way, like every single time I do some kind of identity project, the solution is always completely different than the one before. It's wholly dependent on the requirements, the situation, the whatever you have going on behind the scenes. There's never like a single answer to say always do X or Y, which I wish there was. So in this one, like everything that I'm going to be showing you is completely dependent on the scenario that we're in. If I was presented with a different scenario, I have to reevaluate all of those different kind of questions all over again. It's just that complicated, which is why I'm not a security consultant. I like things very simple, where I just talk to a database and that's the end of the day. So our very first question was, okay, how do our services authenticate? How should they make sure that the caller is who they say they are? Now, we already sort of eliminated the flowing of a user token, so I can't just take the auth0 token and just say that's what we're going to use behind the scenes. One of the big reasons you also don't want to do that is because that token for the browser may have claims associated with it that you don't want to expose in your backend services. So your backend services may have a very kind of coarse-grained set of claims that they expose that I don't want to allow anyone from the outside world just to be able to call anything. You want to have sort of a separate level of authentication and authorization for those backend services. So for us, we went through the process of like just Googling, okay, how do you authenticate services in Azure? And Azure has actually not bad documentation in this. And they had this nice little table that said, here are all the different kinds of scenarios that you'll run into. Here are the different OAuth flows that you can use for that specific scenario. And here's also who it's going to work for. So one of the things with Azure Intra or Microsoft Intra ID, Azure AD, whatever, is it's not trying to be a authentication provider for anyone. They're really trying to lock you into kind of like Microsoft world. So they don't work for just anyone. Whereas something like auth0 or Okta may work for kind of more users, more audiences. But we were inside of Azure, so we said we're going to go ahead and work with what they've got that works well. So each of the scenarios, we'll walk through one. So first up, a single page app. Well, we do have a single page app, right? There was the Angular app at the front that was talking to our backend for front end, but that thing was using OAuth. I'm sorry, it was using auth0 for its authentication flows. So we were going to re-implement that in our backend systems. It's not a web app. Is it a web app that calls web APIs? I mean, kind of. It's a backend for front end that calls other APIs, but we also had scenarios where we had backend systems that were calling our app, so it wasn't quite the same as that as well. We also had messaging applications and like background scheduled applications that didn't have any sort of user associated with them. So we couldn't really use any of these ones that assumed that a user logged in. So that pretty much eliminated any of the auth code flows. So the first like 5 flows were not going to work with us whatsoever. So finally we get to the interesting ones. These ones at the bottom that says, are we a web API that calls web APIs? Actually, yes. It's a backend for front end API that calls other APIs. So that could work. And the last one is just like it's labeled in the documentation as daemon app that calls web APIs, but it's really just like everything else. This is the when everything else doesn't work, then finally you get to this last one, which is just client credentials. We prefer to use the top one, a web API that calls web APIs. And for that one, it can use the on behalf of flow. So the idea here is that you already have a valid token from some other system or the identity provider. So if the user logs in, we get a token. And instead of me flowing that token through to other systems, I acquire a new token on behalf of that user so that original user can't use that token to call into backend APIs. Instead, we have to go through this middleman of on behalf of to call our backend APIs, which meant that our backend APIs were protected from direct access. But there was a problem with this in that the audience is this, it has to be another intra ID identity. So it has to be a work or school account, whatever that means again, I don't know. and then or a personal account, which I think just means like it's a live.com. That's the only time I see live.com ever show up again, or it's a Microsoft online, Azure AD actual, sort of corporate account. Our users were not that though. So I would have liked to use this, but Microsoft's product was not nice enough to use this, or wasn't flexible enough for us to be able to plug in other identity providers. So that was out. The last one on the list was what we had to use, client credentials. So this is a whole, like, the moral of this whole story is basically use client credentials, unfortunately, but that makes the most sense for internal service communication. We did have like even more options of things like mutual TLS was also an option for us. But the thing we kept running into was that we had to have something that was more flexible and wasn't so tied to very specific implementations inside of Azure. We had to support on-prem clients being able to talk to us. And so for us, that meant just to use the client credentials flow, which is basically a service account with a service username and a service password with the service password protected. So the next thing we had to worry about was how do we then authorize? So who can access what data? Now this was, again, healthcare data. So we had to really concern ourselves with making sure that the right applications can access the correct data, and then other applications can access the other data. So one thing we weren't able to do were things like individual user authorization for data. So we could have done that with like passing user IDs through every single request. But the thing we kept running into was that we didn't always have that. So for backend service accounts, like a daemon application or messaging application, they don't have a user that authenticated. So like, well, what is it if it's like sometimes the user ID is there and sometimes it's not there? But if the user ID is there, then authorize. But if it's not there, let them get everything. We're like, just don't even worry about the user ID. So in terms of authorizing who should see what data, we wind up doing that at the boundaries as opposed to each inside every single service. But in Azure, though, we did want to make sure that we didn't let just anyone with a valid token internally call our service. We wanted to make sure that only the services that we had validated could perform this user-level filtering of data could call our service, and no other services. So Azure itself offers two options for authorization of who can call which specific API. And it's effectively, one is ACLs, access control lists. And the idea here is that a server will check the claims on the token and perform any kind of custom logic whatsoever. They want to say, okay, they have this claim, they can be able to access this data. So this is just basically do it yourself, this first option. So things come in the token, check things in the token yourself, and that's all you can do. The option that Azure itself provides for you out of the box is through application permissions. With application permissions, we define custom roles, and I put quotes around that because they're not really roles, they're just permissions. And then we assign those permissions to specific principals, which can be users, groups, or groups of users, or identities, or applications. And with that assignment, I can say that this application can be able to call these endpoints because I've validated that that application is able to perform that correct filtering of the information. And then inside of that token that we get a roles claim that tells us this application has been granted these roles, which are just permissions. And then the server then authorizes those roles to say, make sure the token has those appropriate roles. So in order to kind of validate this with the customer, we boiled this down into a simplified proof of concept application. There was a single server application that represented our backend microservice APIs that was hosted inside of Azure. And then we had two different kinds of clients. One client was an external client. That external client was hosted not in Azure. For the client themselves, that client was hosted on-premise, but it's just not in Azure. And then the other client was hosted inside of Azure. And the reason why we differentiated this is because if you're hosting inside of Azure, you actually get a lot more benefits to authentication and authorization. Whereas if you're on-prem, you're just basically using the client ID and client secret client credentials flow of OAuth 2. All right, so the last piece of the puzzle was we are defining explicit permissions for all the activities that you can perform on our APIs. So we're saying that some clients can perform some things, some clients can perform other things. And that was the best we could do to say, okay, some of this data we have is more restricted than others. So some services just may want to call us and say, what are the countries that exist? And we have an API that returns countries. But if it's more like, what prescriptions have been prescribed for your child? Well, that has to be much more restricted than just like more open data. So we had to define, okay, what are these different permissions we should assign to each of these kinds of endpoints that we are exposing? In this really dumb application that I've created for today's demo, it is just a CRUD application that has like, get, put, post, delete. And so like the most obvious way of sort of assigning permissions to each one of these different operations is to say, well, we have create, read, update, delete. Why don't we create a permission for each one of those, where I have a permission or a role that says I can read it, I can update it, I can create it, and I can delete it. This may be too fine-grained for your permissions. So this becomes sort of a business discussion of what are the kinds of operations being performed in my application, and how should I design the permissions and authorizations to be able to turn certain things on and off. Now, I keep saying it's a permission, even though it's labeled role. These are not like the traditional role of I am an administrator, I am a power user, I am a manager. I don't like that kind of role-based authorization. This is action, task, permission-based authorization. Can you perform this specific operation, yes or no? And we can roll that up into groups or users or roles or whatever. But in terms of authorizing specific actions, I'm going to use a more finer-grained approach here. This was too fine-grained for us, though, so we went with something more basic, which is, can you read it or can you write it? And that was basically good enough for us. All right. With that, let's go ahead and switch over to our demo, which will be exactly this, where I have a server running inside of Azure. This is an API client running inside of Azure. I've got an Azure client, which is an API client running inside of Azure. And then on my laptop here, which is connected to Wi-Fi, yes, I think so. And then that will be running my external client calling out into Azure to authenticate and authorize against that API. All right, so I am using, to help make this easier for me, I am using hold on, here we go. To make it easier for myself, mainly, to be able to create all these resources in Azure, I am using Pulumi. This is not a Pulumi talk, but it makes my life easier, so I'm going to be showing Pulumi. You don't have to use it. But I also found that Azure's portal to setting all this junk up is really confusing. Like auth zeros is slightly less confusing, but it's still, you really have to understand everything, how it's put together. And Azure, you really have to understand how it's all put together. So by using Pulumi, I found that's actually a bit easier because I'm defining things in terms of objects as opposed to clicking around inside a portal. I will still show how it looks inside the portal, but I will be doing everything inside of Pulumi here. All right, so the very first thing I need to do is create my web application inside of Azure. So inside of Pulumi, there's this concept of stacks. That's unimportant. And a stack is a series of resources that are going to be applied against my external cloud provider. So the first thing I'm going to be doing is creating a server object. So inside of here, I'm going to be creating a resource group, and then an app service plan, and then finally, we'll skip the Azure resources, I'll be creating my Azure app service. This is not going to be that interesting. I've got a Linux app service that is running .NET 6, well, it's .NET Core, but .NET 6, and it's just going to be running the API, just .NET whatever. So when I apply this, it's going to create the Azure app service up in Azure, and I think I can then deploy my Azure app service to that. So my Azure app service, my server is right here. So after like just doing kind of file new Azure, file new web API inside of Visual Studio, the next thing I need to do is add some API authentication. But to do this, I'm going to say I want to create this API that's going to be using Azure AD or Intra ID. I'm going to keep saying Azure AD because all the packages and all the assemblies, all the namespaces are still and will always be Azure AD. The Intra ID stuff is just pure marketing junk, so whatever. I'll call it Azure AD. So I need to make sure that when my API is called, that it's going to authenticate the token based on Azure AD authentication. So to do that, the first thing I need to do is pull in a package, the Microsoft Identity Web Package. So that one right there is the package if you're a server in Azure authenticating against Azure AD. You want to use that package there. There's like 3 or 4 different packages I'll show today. They're very they're targeted for different scenarios. This one is if I am a server authenticating requests with Azure AD. So once that's pulled in, I need to configure my web API to add, this is like, to add Microsoft Identity Web API authentication. One of the longest methods you'll see in existence in Microsoft today, but it is at least descriptive. Like you can't argue about what it means. It is to add Microsoft Identity Web authentication, not Azure AD or Intra ID, because when they made this package, it was Microsoft Identity. So they can't change the name anymore. So what this is going to do when I say add Microsoft Identity Web API authentication and down here at the bottom to say use that thing as well, use authentication and use authorization, it's going to add the correct services to say when I receive an incoming request, check the incoming request for a bearer token. And if that bearer token, after decoding the JOT, has the correct origin of Microsoft Identity Provider and all the other kind of JOT junk you do of validating the certificates, validating the signature at the bottom, all that sort of stuff, that's doing all that for me based off of my configuration. The second piece I need, though, is in order for me to say I want to validate against Microsoft Identity Web API authentication, is I have to identify myself as a resource that can be authenticated against, which just simply means like if I'm something that can have permissions associated with it, then I need something that can identify myself as something that is a securable resource. So that piece comes in back over in Pulumi. That says, not just I am a blank service that has no authentication associated with it. The next thing I need is to be able to say I am something that can be secured. This is the big first sigh of my talk, because at this point I have to switch over to the Microsoft terms for how to identify some kind of secureable resource. Every single identity provider, Azure, Okta, whatever, Google, Amazon, whatever, has their own way of identifying a secureable resource. And the idea is that you can define your security rules, your security permissions inside of that cloud provider. And when you acquire a token from that cloud provider, it says, I am going to apply those rules against that specific secured resource. But first I have to define what is that secured resource. In Microsoft's world, they have like 3 or 4 names, I think, for what this secured resource is. In Pulumi, it's called an application. I'll go to the portal in a second. It's called something else there. But in Pulumi, it's called an application. And what this is just defining some kind of resource that can be securable. So that when I get a token to say, I want to authenticate against Azure AD, but I also want to acquire a token to be able to call this specific resource, I need to identify what that resource is. And inside of Azure, that's called a server application or an application here. So in this case, I just give it a name. It's a server. That's it. And then out of that, I get right here an application ID. I'm going to go over to the, there we go, the server. This is an intra ID inside of Azure. And what this is going to give me is some ID that identifies this specific thing that can be secured. So back over in my server, in my API, when I say add web API authentication and I give it the configuration, inside of my configuration, I give it the ID of the client, which is over here, the ID of the client. F2BB, F2BB. So when a request comes into this server, it will not just say, do you have a valid token from Azure AD? That's not good enough. Do you have a valid token that says you can talk to me, which is this specific client, that F2BB thing. So if I were to run this now, and I try to execute code or like try to send requests to the API, I will get unauthorized because I don't have a token against that specific client. So the next piece I need to worry about is, well, then how do I acquire token to be able to call this API? Now, the first thing I have to worry about before even that is I'm a developer. I need to call this API while I'm developing this API. And if I can't like actually execute it via Swagger, then nothing is going to work. So before I even worry about like external clients and internal clients, I have to worry about me as the developer being able to call this API. So to do that, the way I can assign, I can actually acquire token against that API is I can authenticate with any kind of principal that Microsoft supports, which is going to be a user, a group of users, or this application thing. The application things are going to be the actual applications running, but for me, I'm a user, so I need to get my user to be able to acquire token against that API. So back over here, where I created the server, I am going to make my life a little bit easier, I'm going to create, I didn't mean to click that one. I hope I didn't kill it. Nope. Oh, here we go. As new developers come on the team, so basically the problem is that in order for me as a kind of human to be able to call an API that is secured via client credentials, it's not good enough to just to say, are you just a user in this organization? I have to actually have access to the resource because it's a protected resource with very specific permissions. So in order to make my life a little bit easier, what we wind up doing is creating a Azure AD group that would be all the different developers in one group. Then I can grant permissions to that group as opposed to the individual users. And then for users, all we had to do was then add them to the group. So I would set up the local group to say, okay, let's go ahead and find me as the user, find the dev group, which is this a local dev group, and then add me as a member to that group. So I'm going to add me to the group, and then once I'm added to the group, if I add permissions to the group, then I get those permissions as well. So back in my server, over here, I would, my stack, there we go. After I created the Azure AD resources in the server, I would assign the specific roles to that individual server. So before we can actually call this, though, we have to authorize every single request against those specific roles. So the last piece on the server side, before we can actually call it with a token, is then to say, how do I make sure that individual, not that just the individual request comes through that has a token for my resource, but also has the appropriate roles associated with it. So for that, we needed to map the incoming roles from the Azure token to the individual claims on the identity when I'm running my API. So right here, I've got this like weird thing to clear I don't know, that I just copied and pasted that code from something in Microsoft documentation. And then I said, in my settings that said, when you are getting an external claim that has a roles claim inside of it, then go ahead and map that roles claim from the incoming token to the roles in my principal. So that in my actual application code here, we say we want to authorize this controller, so all the API endpoints in this controller will validate that I have a token, but each individual action, I will say, make sure that they have that individual role. So instead of me having to like parse a token, do kind of like some kind of JSON, deserialization, whatever, instead that's already been done for me, and my application code doesn't care like what the identity provider is. It doesn't know anything about Azure AD whatsoever. All it knows is that I am going to authorize my principal to have, or my identity to have that specific role. Where that role came from, I don't care. Doesn't matter. That's been done by middleware. For me, my application code is just, do they have that specific role? That's really what I wanted to get to for my teams. Before we really dug into Azure AD, they were doing this sort of token like parsing and manipulation themselves. And what I wanted to get to is a more higher level, like we should just authorize a role and not worry about where that role came from. That should be done for us by our middleware. So it is now. So let's run this. I've got the all this stuff hooked up in my API. My server application is going to it's going to assign all of the roles associated with it. And then when I run it, it's going to authorize those roles against my token. There was one additional piece I had to hook up with Swagger. So I'll provide a link to the code later that shows exactly how to hook this up with that, because typically if I'm trying to call an API that says you can only authorize against client credentials, they won't actually let you authorize through the browser because you shouldn't have a client secret in the browser. So it just won't let you do that. So I did have to do some additional work to enable this additional authorization flow. So I'll say, yes, go ahead and authorize and call the API. So what that did behind the scenes was, it was very quick as I had already authenticated, was launched up the browser to redirect to Microsoft's login site. It authenticated, passed the information back to the server over here, and then finally, I'm actually inside of my my controller action that has already been authorized. And if I look at the let's go to the current user. Is in role. I can say, are you in the to-do.read role? And it'll say true. And the reason why it was able to do that is because the token, so I just spit it out to the screen here. If I were to go over to a token deserializer, we can see that, yes, my legal name, James, sure. As part of that, it said my identity provider is live.com because it's a personal account, whatever. The subject, and actually over here, the thing that I'm trying to authenticate against is the client. And then finally, it says that I've been assigned these two specific roles, read and write. And those roles got assigned because in my Pulumi code, in my Pulumi code right here, I had assigned the read and write roles to my local dev group ID. So this was called over here in my initial Pulumi setup where I said, go ahead and pass through the Azure AD resources, which is the group that was associated with it. And so when I say server.assign roles, it's going to assign the read and write roles to my local dev group. And by assigning those roles to my local dev group, that means that when I acquire a token for the specific resource, it's going to give me, in that token, those two to-do read and write roles. So now I can develop against it. The next thing I want to do is then be able to call it from different clients. So this is just like me building the server. The next part our team was doing is in building each individual client. So the first client is an external client. So this external client is an on-prem system. So it's not one that's inside of Azure. I can't use all like the Azure goodness. So for an on-prem system, if I don't have any user token available to me, I just don't have that. This is not possible. And I still want to authenticate that system with mine. Instead, I have to use the OAuth 2 client credentials flow. But because I'm on-prem, I have to use like a client ID and a client secret. There's just no other option available to me. It's just user ID and user password, except those user ID and user password are that specific client system. So inside of Pulumi, the way I'll manage this is external clients. There we go. Is known as an app registration, which again is a stupid name, but it's still just an application. Again, there are like 3 or 4 different names of this in Azure. There's app registration, application, enterprise application, and then just application. I don't know why there's so many names that there just are inside of Azure. So I have to identify this thing as something that's going to call this other thing. So I will create this Azure AD application that will identify this client application as something that can acquire a token. I need a secret associated with that. So I need to be able to, there's many different ways of doing this. This is the simple way of just acquiring an application secret. And so that secret is just going to be a password, an application password. I will store that somewhere secure. For me, on my laptop, it's just like user secrets here. In Azure, I'd put that in like Key Vault or something like that. This is not the only way of doing this. You can use certificates as well. But again, for easy mode, I'm just going to use application secrets. And then the final thing I need to do is, in order for me to assign permissions to this application to another application, you have to sort of raise this application up to be a service principal. The service principal is really the thing that can be assigned permissions to. So I imagine in Azure there's like a permissioned principal table somewhere that is all the principals that are users, groups of users, and applications. And so this elevates my application into something that can then be joined together to have application permissions for. Yes, so back over in my stack over here, I'm going to assign the roles for that external client. In this case, I'm only going to assign the read role, just to show how it looks different between a read and read-write roles. So with that assigned, if I were to go over to my server, this is too big. There we go. I can see over here in my app roles, I've got to-do read and to-do.write. Those are defined on the server side. And if they want to look at the actual permissions, who has access to this, that is over on, actually, roles. I can look at these roles. And as part of that, actually, I have to go to the enterprise application, right? This is the stupid thing of Azure's user interface. If you want to see the kind of permissions associated with each of these, you have to look at the enterprise application. I don't know why. That's just the way it is. There's an enterprise application up here. And now I can go look at the roles and administrators and the users and groups. There we go. No? Oh, there they are. Okay. Took long enough. So here we have the Azure AD example external clients, which is a service principal that has the to-do.read role assigned to it. So there's somewhere in Azure that has this table of applications and principals and some join table that pulls all these different things together. And we also see my local dev group here as well. Now on the client side, it's not that interesting to get that stuff working. I will pull in a Microsoft.identity.client package. Again, I don't know why the names are so different here, but this is, if you're trying to access a secured resource inside of Azure, then you're going to use that package. You may have already seen this. If you're accessing like databases, Key Vault, those sort of things inside of Azure, this identity client package comes with it. But we can also use this package to access any other resource that we define inside of Azure as well. So inside of our startup, we will configure we have an API that's just an API client that's just constantly calling that API. And we're giving it to the client ID, the client secrets, and of course the tenant ID because we're inside of Azure AD. There's quite a bit of stuff to set up the token acquisition, but the end result inside of this case is our middleware is that we're going to call Microsoft Identity Client's API to acquire a token for our client, which is our client ID and a client secret. Once we acquire that token, then we're going to add a bearer token to the outgoing requests, and then all of our API requests will then have that bearer token automatically applied. So in terms of our client code, it's really quite simple. The client code is just, I get a strongly typed HTTP client, and inside of here, we're not actually applying any headers or anything like that. We've done all of that header acquisition and token acquisition, and then applying it to the headers on outgoing requests behind the scenes with middleware. At this point, it is just straight up, just call the API from our client code. Now, external clients are annoying because we have to worry about this external secret. What's really interesting is if we're inside of Azure, then we don't have to worry about these client secrets anymore. We can instead use Microsoft Intra ID to define these identities instead of having client IDs and client secrets just kind of pushed away over somewhere else. So for an Azure client that is an Azure App Service, right, just an Azure App Service is a Linux app service, what we're going to do is assign a user-assigned identity. So this Azure App Service will be running as a specific user that we define as this managed identity. And this managed identity that is assigned to this Azure App Service here, if I go over my Azure portal and look at there it is, App Services, and the client, now its identity is something that we have defined ourselves. So instead of running anonymously, it's running against this specific identity that Azure manages. And then inside of our Pulumi code, we can then assign the roles to that specific client. So over in my server, I can assign the read and write roles to that managed identity. And now, whenever I acquire a token as the client inside of Azure, I no longer need a client ID and client secret. Because I'm running inside of the Azure environment, then inside of my configuration for that client, the internal Azure client, you don't see anything that's like, here's my client ID and client secret. I only have client ID. I don't have client secret anymore. Not something I ever need to worry about ever again. That is one of the advantages that we saw of using Azure Active Directory or Enter ID, whatever, was that I don't have to have client secret as something I have to manage ever again, because those things do expire. I have to rotate them. I have to make sure that the access to those secrets is secured, all that sort of stuff. Instead, I just say, here's who I am. I am this client. And it is still a client secret that still does exist, but it's not something that is visible to me as the developer or end user, or even as the infrastructure person. It is just something completely managed all inside of Azure itself. So I just say, I'm this client. And again, my client code itself, and this one it's an API that this is my BFF, an API that calls other APIs. So we can assume that this API is secured some other way. But my clients themselves like don't have any sort of authentication, authorization, token acquisition code whatsoever. That is taken care of me behind the scenes by the Azure libraries calling out to Azure, getting the token for me based on my client ID, and managed identity somehow, and be able to get that back and call my APIs without me having to worry about it too much inside of my client code. So me as the architect in the system, this is what I was trying to get to. Very simple API calls that were like, you don't have to worry about all the token acquisition behind the scenes. That's done for you by the libraries underneath the covers. So in the client example, this was using the Azure.identity library. And this is for the inside of Azure clients. For outside of Azure, we had to use the other Microsoft web identity clients. But in either case, we can acquire that token, attach it to each request going out the door, and then our client code itself then doesn't have to worry about having to manage all that sort of security behind the scenes. So that was that was like 12 months of my life distilled into 1 year or into one talk of how to do Azure ID authentication and authorization. This may or may not be directly applicable to you, and that's fine because, again, every time I run into these scenarios, it's like I have to completely throw everything out and start over all again because every situation is completely unique. But at least I hope you got something out of this, which is like, don't not do security. That's never a good thing. Yeah. So thank you all very much. I hope you all have a great rest of the conference.